Hello and welcome back to our tutorial series on data analysis with R. This is the fourth Tidyverse tutorial, Joining and Merging. My name is Wouter van Attenveld of the Vrije Universiteit in Amsterdam, and you can find the series of tutorials and all the handouts on vanattenveld.com/r. And if you go there, you will see that it contains a link to the video tutorials and to our upcoming book on computational social science, but it also has a link to our GitHub page, where we have all the various handouts here, and the one we're looking at now is the one called Combining and Merging Data. So if you follow these links, then you can actually get the document that has all the codes that we're using here, so it's easier to follow along. Let's get to business. We will look at a real example of primary results data later, but first we'll do a little fictional example because that makes it easier to explain the various types of joins: inner joins, left joins, right joins, full joins, semi-joins, anti-joins, plenty of joins. So we will have a fictional data set containing a bunch of astronauts, which are obviously called Jeb, Val, Bill and Bob, and they're male, female, male and male. And then we have a set of missions, and let's actually include an unknown astronaut here that also went to the moon. So basically what this says is that astronaut number 1 went to ISS and the moon, astronaut number 2 went to the ISS, astronaut number 4 went to Mir, and our mystery astronaut number 5 went to the moon. So suppose we want to join these two data sets because, for example, we might want to know how many women went to the moon, right? So we want to know, want to combine the gender information with the mission target information, right? So we want to join those two data sets. Now, fortunately, they both have one shared column, astro ID, that refers to the astronaut number, so that makes it a little bit easier, and we can actually immediately run a join. In this case, we'll run for example, an inner join as the first one, and then we'll see what happens. So we'll join in the astronauts with the missions. So what you see when you do an inner join is that we have results for row 1, astronaut 1, astronaut 2, and astronaut 4. We don't have results for astronaut 3, and we don't have results for astronaut 5. The reason for this is that an inner join only keeps the data where the rows occur in both the astronauts and the mission data set, right? So it gives you the intersection of the rows. So we only get results if there's astronauts and if there is a mission. So Bill didn't have a mission, and astronaut 5 didn't have astronaut information, so these are both dropped. What you also see is that you have multiple rows. For example, we have 2 missions for astronaut 1, then these are actually duplicated in the resulting data set, right? So we have 2 rows for astronaut 1 and 1 row for astronaut 2 and 4, and 0 rows for astronaut 3 or 5. This is an inner join. The opposite of an inner join is a full join. So we can do a full join, and a full join will contain all the rows from the astronauts and all the rows from the missions. So we have Bill here, and he'll just not have a target, and we have our mystery astronaut 5 here, and it will just not have a gender and a name, and these are all missing values. So where inner join only gives you rows that occur in both data sets, a full join gives you all the rows that occur in either the left-hand side data set or the right-hand side data sets, and will give you missing values if it couldn't be found in the other data sets. Now, in between the inner join and the full join are the left and the right join. So a left join will give you all the astronauts, and it will give you any missions if they have them. So we will have Jeb, Val, Bill and Bob. We'll get the missions for Jeb, Val and Bob. Bill will be in the data set because it's on the left hand side, but there will not be a mission located because it's not in the missions. Astronaut number 5 is not included because it's not in the astronauts file. As you might guess by now, the right join actually inverts this. So the right join does not include Bill because it doesn't occur in the astronauts, but it will include astronaut number 5 because it's included in the missions, right? So the left join gets you everything from astronauts, and it gives you the missions if there are any, and the right join gives you everything from missions, and it gives you the astronauts if there are any. In most cases, the joins we will be using are either the inner join, if we want to make sure that we only have complete records, or the left join, where this is basically maybe our master record. So these are all the astronauts that we have, or these might be all the states that we have, and these are extra information on some of our astronauts, but we don't have that information on everybody, but we still want to keep everybody from this master file. So we'll be using the inner join a lot, and we'll be using the left join a lot. Now finally, there's two more kind of joins. There's semi-joins and anti-joins. And let me actually copy the left join here because we're using that one a lot, so then you can see it going there. The semi-join actually is a filtering join instead of a mutating join, as they call the other joins. And if we do a semi-join, we can basically say, I want to have all the astronauts that have a mission, if I would be able to type. And then you can see here that we get astronaut 1, 2, 4. We only get information from the astronauts data sets, but it's filtered on having a row in the other data set. So semi-join basically does the same thing as a left join, right? It only gives you the rows that occur in both of them, but rather than sorry, it's not the same as left join, it's the same as an inner join, but rather than also combining the data, it only returns you the data from the left hand side data set. Now finally, anti-join is the opposite. An anti-join will only give you astronauts that don't have a mission. Semi-join gives you astronauts that do have a mission. Anti-join gives you astronauts that don't have a mission. So both of these are basically filtering joins that are useful to filter one data set on whether the rows from the data set occur in the other data sets. And so we've seen inner join, we've seen left join. And so inner join gives you only the rows that occur in both. Left join gives you all the rows from the left, and any information from the right is added. Right join is the opposite of the left join, and full join actually is the opposite of the inner join. But before we can start joining them, we need to do two things to prepare it. First, we want to change the results so we only have the state level results. So what we're going to do is we're going to do a simple aggregation. So we group by state, party, and candidates. And we're going to summarize the votes as the sum of votes, right? So we're going to get the total amount of votes that every candidate got in every state. So we'll call this the results state for the state level results. And then finally, the schedule has the date column, but the date is not actually date. The date is a character written in American date formats. So we're going to mutate that to say to make sure that the date is an actual date, and then of course we need to tell him that it's an American format. An American format is the month followed by the day followed by the year. In this case it's a lowercase y because it's only 2 digits. Right, so after we've done that, you see that it actually, I call the data, that's not so good. Let's call this dates, and let's just read it again. And so now you'll see that the schedule contains a date variable, which is a proper date, and it's now also written down in ISO notation. Alright, so now we could actually start joining them. So we could do a inner join of the results at the state level with the schedule information, and this will tell us that Bernie Sanders actually got so many votes at this moment. Now of course the number of votes isn't terribly interesting. We probably want to do a little calculate what percentage that is. So we're going to add the total, that's the sum of votes. And so now you see that this is the sum of these 2 votes, and for the Republicans it's the sum of these 5. And the reason I didn't need to group by is because it was already grouped by state and party, right? So because we group by state, party, and candidate here, if you do summarize, it drops only the outermost grouping variable, so the data was still grouped by state and by party. And then we could compute a percentage as the votes divided by the total. Right, so we see here that in Alabama, Hillary Clinton got 80% of the vote of the total states. So this we can now easily plot by doing a ggplot. And actually, let's first only take the Democrats because it's a little bit easier. And we're going to ggplot this data, and we'll put the date on the x-axis and the percentage on the y-axis, and we could get the candidates as the color and do a little line. right? So here we see how the different candidates on the Democratic president primaries, how they did. So in this case, it's not terribly interesting, right? So because there were only 2 candidates, so if Bernie was winning, Clinton was losing, the other way around. So that's actually also only give us Clinton in this case. And then we get a line on how Clinton was doing. The reason you get these funky lines is because sometimes there's multiple primaries on one day. We could avoid that if we would actually now group by dates. And either get us the total results or get us the average results, but let's do the average here. So we group by dates and we summarize saying that and actually we probably want to group by party, candidate and date, and summarize that the percentage is the mean of the percentage. And now we get a much nicer line where you see that Hillary Clinton actually was pretty much around 50% for most of the line. We could now look at how the Republicans are doing, and of course they have more candidates, so it could be more interesting to look at. And then we see how the different candidates were doing, and of course here we see the rise of Donald Trump. He was actually doing quite well in the beginning. Then at the end, Ted Cruz around April was doing better in a couple primaries, but in the end he clearly was winning the primaries. Now, of course, the plots and the data isn't all terribly interesting, but what I wanted to show you is how knowing how to do the join actually allows you to join different data sets together, so you can join the results with the scheduling data set and create a visualization there. As a final example, we're going to now join the results at the state level with the facts data. So the facts actually give us for each state and for each county gives us all kind of different facts like the population, the ethnicity, the gender division, etc. Education level, all kind of interesting facts. So we're going to join them, but the problem is if we would just join them, it tells us there are no common variables, and the reason for that is that here it's not called the state, it's called the area name, because it can be the country, the state, or the county. So what we're going to do now is actually we have to supply the by arguments to tell it how to join. So we're going to say by equals and then we say that on the left hand side it's called the state, and on the right hand side it's called the area name. And now you can see that in Alabama, where the Democrats, Bernie Sanders, got so many votes, and then we have all the different population counts, and we could use this of course to for example see whether there is a link between the maybe the gender division and the Democrats, and whether Clinton or Bernie got the state, right? So we could do something like let's first keep only the Democrats. Are they called Democrats or Democrats? No, apparently it's called Democrats or Democratic. Let's actually look upside where it's called Democrats. So party equals Democrats, and then let's keep only the candidates, the state, the candidates, and then the number of votes and a gender division. So let's see there, sex, female, percent. Sounds about right. And so now we see that in Alabama, Bernie Sanders got this many votes, and there's a more women than men in Alabama, while in Alaska there's many more men than women, probably because of the offshore and various industries. So now we are going to repeat the grouping by there. So we are going to, it's actually already group by state and party, so we can immediately get the percentage command that we used here as well. And so we now see how many what percentage of the vote Hillary got, depending on the amount of women there. So now we can say that we filter where the candidate is only equals to Hillary Clinton, and we will call this the Clinton women data set. Let's actually add one more. Get the college educated voters, which I think is called pop college grad percentage. So we're going to get that one as well. So we're going to increase our selection to also have pop college grad percentage. Is that correct? No, it is pop college grad PCT for percentage. And it's called capital P. There we go. So now we have our data sets, which says what percentage the vote Hillary Clinton got, what the gender division is, and what percentage was college graduated. So now we could, for example, test a correlation between the percentage of votes that Hillary Clinton got and the sex female percentage. And of course, this should be from the CW dataset. And so it's actually a fairly strong correlation and very highly significant as well. So in states with more women, Hillary Clinton actually got a lot more votes. And now let's have a look at the population college grad percentage, and that's actually negative. So interestingly, Hillary Clinton did worse in areas with a higher with more college educated respondents, while the p-value is just insignificant, right? It's 0.08. Of course, the test or the plots, these weren't really what we're about, but what you see here is that to join, and you can also join multiple data sets if they don't have the same columns, and then you need to use supply to by commands to actually tell the computer how to join those data sets. Alright, now as before, have a look at the handout, see if you can follow along, see if you can play around a bit, see if you can maybe get some other data, and see if you understand the difference between all those various joins. Alright, good luck and see you soon.